Hey, welcome back. In this lecture, we are going to do LED toggling using multiple tasks. We have 4 LEDs on Discovery board: green LED, orange LED, red LED, and blue LED. If you are using any different board, such as Nucleo board, then there is only one user LED available. For other 3 LEDs, you may have to arrange some external LED. This exercise particularly works on the Discovery board. We are going to use task 1 to toggle green LED for every 1 second. And we are going to use task 2 to toggle orange LED for every 500 milliseconds. And task 3 to handle red LED, and we use task 4 to handle blue LED. Task 4 toggles the blue LED for every 125 milliseconds. When you run all these tasks at the same time, then all the LEDs getting toggled at the same time, like kind of concurrent access. Let's implement this exercise. For that, in this lecture's resource section, I have given you 2 files, led.c and led.h. You have to add that file to the project, to the current project. For this application, we are going to use software delay, that is for loop based delay, to toggle the LEDs. That means to give a delay between LED on and LED off. Later we can change this software delay to timer based delay. We'll do that later. Let's get back to the IDE, and all you need to do is go to source folder and add led.c, which I have given in the resource section. Go to ink folder here, just add that led.h. You can just copy and paste. After you add led.c and led.h, you have to modify main.c. In the main.c, first include led.h. After that, let's go to task 1. Here, let's remove this and let's toggle green LED. Just write LED on. If you want to see what are the functions supported by led.c, then you can just go to led.h and you can see all these functions. This function is used to do LED init. This is for LED on, this is for LED off, and this is for delay. What you should do now is, first you have to use LED init. Copy this LED init, go to main.c. Before calling this SysTick timer, you just call from here. This initializes all the LEDs of Discovery board. After that, use LED on. For the LED on, you have to send the LED number. That again you can get led.h. You can use LED green, LED orange, LED red, and LED blue. And for the delay, you can use 1 milliseconds delay or 1 seconds delay, 500 milliseconds delay, 250 milliseconds, like that. This is a delay count for loop. So if you want to give delay, then you have to use delay function. Delay function is again implemented in led.c, and that is currently the software based delay that is based on for loop. Let's go to the main.c, LED on. Using for loop based delay is actually bad, but that's okay. For a time being, we'll use this. Later, we'll introduce timer based delay. That would be more efficient. But first, let's try with simple. Main.c, here I would use LED on, LED green, and then call delay. Use the delay count. Delay count for 1 second delay. This happens to be some number which causes for loop to generate 1 second of delay. After that, let's go back. Here you have to call LED off. Again, you have to use LED green and give some delay. LED on, LED off. LED green toggles with a delay of 1 second. Let's copy this, paste here. This is for LED orange, and here we are going to use 500 milliseconds. Let's again copy this, paste here. So this is for blue and this is 250. Finally, let's code for task 4 handler. This is red and this is 100 milliseconds or 125 milliseconds. That's it. Initially, it keeps all the LEDs off. Let's try this code. Let me build the project. There are no errors. Let's run this code. Hit run and you can see that LEDs are toggling. But you should also observe one thing, that the LEDs are not at all toggling in the way we specified the delay. For example, LED green is toggling for every 4 seconds, right? Not for 1 second. That means the delay is extended by 4 times. Why is that? We can analyze like this. Let's say task 1 is scheduled to run and it actually turns on its LED here, green LED. Then it just wastes the CPU time by getting trapped in the for loop. This is wasted. Approximately 1 millisecond is wasted here. After that, task 2 runs. It turns on its LED here, let's say LED orange. And again, it wastes all these CPU cycles by getting trapped in the for loop. So again, task 1 will get scheduled after 3 milliseconds or after 4 milliseconds. That means you can see that all these CPU cycles are wasted. That's the reason why delay is extended by 4 times, because you are almost wasting 4 milliseconds here. What's the better solution? The better solution is introduce a timer based delay instead of software based delay. The task should not waste any CPU cycle. If they are done, they should leave the CPU. That's why we have to introduce blocking state for tasks. When a task has got nothing to do, it should simply call a delay function which should put the task into the blocked state from running state until the specified delay is elapsed. That means we should now maintain 2 states for a task. One is running state and another one is blocked state. The scheduler should schedule only those tasks which are in running state. The scheduler also should unblock the blocked task if their blocking period is over and put them back into running state. If you introduce blocking state for the task, then you can solve this issue. The goal is not to waste any CPU cycle. Here task 1 turns on the LED, so leave the CPU for these many amount of time. Make task 2 run. In that way you can achieve the realistic behavior on LED toggling. That is our next attempt and we'll do that in the next lecture.